Alright guys, so this is just a quick tutorial about how to use and set things up with the AVA 3.0 software that we're going to use to analyze all the microcirculation videos for our research project. The first thing that you should do is, once you're booted up into Windows, create a shortcut to this AVA 3.0 folder. So the way that you do that, you just right click, go down to New. Let's just make sure this is all in focus here. It's a little bit tough to see, but basically you go down to New and then Shortcut. It's the second choice, and then it'll basically come up with a window that asks you to create this shortcut, and you browse and you look in and find basically where your AVA 3.0 folder is. So in my case, it's in my computer, C drive, boot camp, and then AVA 3.0, and then you click OK. So I already have a shortcut. I'm not going to bother doing it, but if you click OK and then you go next and then finish, it'll create the shortcut there. Okay, so once it's created the shortcut, okay, you have access to this basically all the AVA stuff for the software, and it'll be really important. These three folders are the most important: experiments, export, and logbook. Okay, so the next step that I'm going to ask you guys to do is to open up your web browser and then go to www.box.com. So once you're in box.com, Box is equivalent to like Dropbox, but it basically gives you a lot more storage space than Dropbox. You'll see that once we go through the process and stuff, you will actually get 50 gigabytes of storage as opposed to the 2 gigabytes that Dropbox starts you off with. So go ahead, sign up for it. I've already signed up. I'm just going to log into my Box account. Okay. So logged in, and once you log in, you'll see that you will eventually have access to this shared folder called microcirculation, and this microcirculation folder will just have the videos that we're going to analyze. So you click on this microcirculation, and you'll see that you'll have a whole bunch of videos that I upload into this folder, and you'll be assigned certain videos to analyze. And you'll see that this video here, patient 33, SL1, pre-op, steady 1, there's actually two file formats. There's a .avi, which is the actual video, and there's a .xfr file format that is required by the AVA 3.0 software to read it. So what I want you to do is I want you to go ahead and download both of these files. So, okay, my download has started. That's going. It's going to take about a minute or so, depending on how quick your download is. And then we'll also go ahead and download this file here. So those two files are going to download. It's going to take about 30 seconds or so. So it's important to make sure that you download both of these files for each video. It's not just a single video. You have the video file and the accompanying XFR file. So in order to do the analysis, you need both. These are basically stabilized video segments. Okay, so I've looked at the video a little bit, and I've picked the best, most stable segment, and then asked the software to stabilize it for you. So you're able to skip that part. It just cuts your work down a little bit. So great. Now we have basically downloaded both these files. They should show up on my desktop. Yeah. So here are the two files. I've set it up so that files save onto my desktop. So what I'm going to do is I'm going to open up first my AVA folder, shortcut to AVA 3.0, and then go into the experiments folder. It should be the first folder. And yours should be empty. I just have a few extra folders here. I want you to take these files and I want you to drag them into your experiments folder. Both the .avi and the .xfr files. You'll need both these files, okay? So once we have that in place, we'll just minimize that, and then we'll start the AVA 3.0 software. So I have a link to it on my desktop. It opens up, choose program settings, you just go OK, and then it'll ask you if you want to perform spatial calibration. Hopefully we've already done this on your computer. If not, get in touch with me and we'll do it on your computer. It's no big deal. So it asks, do you want to recalibrate now? No. Okay. And then basically we just go and click on analysis. Okay. So the reason why we have our taskbar over on this side is that for this resolution of our computer monitor, we can't actually fit the entire AVA software window into this resolution. So we lose a little bit, and the only way we can see the buttons at the bottom, and you'll see the buttons at the bottom, there's a stop, step forward, step backwards, play. The only way we can see those buttons is if we move our taskbar over. Hopefully you don't have that problem with your laptop or computer that you're using and the resolution is high enough. But if you do, just move the taskbar over to the left or right side and you'll be able to work with it. It's kind of a temporary solution, but it'll work. So once you have it open like this, what you do is you go over to this side here. Maybe a little bit hard for you to see on your screen because it's so bright, this video. I hope that it shows up. But you go and you click on the first button here that says Open Video File. And once you click on Open Video File, it'll automatically look into the Experiments folder. And within the Experiments folder, remember we had copied those two files, the .avi and the .xfr files. So you're going to click on this file, the .avi. It's the only one that opens or shows up. Click on OK. It'll have some information. Just leave that blank. Click OK. And then this is what it is. Okay. So you'll see that this is 80 frames at the bottom of this video, and then we can play it. And it's nice. It's nicely stabilized, and it's great. So this is what we're going to use to basically run our analysis. Okay. So the next step is you'll see this little part. There are two sort of sliders here. One of them is the one that moves when we hit the play button, the green one that goes. And we'll just stop that. And the other one that says fragment, and it has this white thing. We want to move this slider all the way over so it tells the software to capture all 80 frames. So now you see between 0 and 80. These are the frames that you've selected. And I want you to click on this button here. It says Use Average Frames. So once you click on this, this is telling the computer to average frames 0 to 80 to create one still image. And it's averaging the frames right now. It creates basically a smoother image, and it might be easier for you to do the analysis with the image, with this smoother image. Okay, so once we've created this smooth image, the next step is basically drawing all the vessels. Okay, so first you want to turn on these little indicators here to actually display the vessels. This is Show Center Line and Show the Vessel Wall. Okay, we want to turn those on. Basically, there are two ways to draw vessels. We can ask the computer to kind of find vessels by itself, or we can draw them manually on our own. Okay, I personally prefer the manual drawing way. I find that when you ask the computer to draw in the vessels, it often has some difficulty, especially in areas where vessels overlap. So I just prefer to do all of it manually. But if you want to ask the computer to draw some, you can go ahead. Basically what you do is you choose basically a thickness that you think is appropriate. So if we want to analyze this very thin vessel, we would choose the thinnest choice right here. And we basically pull and drag like this. And then we wait, and then the computer analyzes it. So you see here, the computer does a pretty good job of analyzing this segment. It gets it more or less spot on. The problem, however, occurs if we go to this area. So you see this area, there's some vessels that are sort of intersecting and stuff like that. If we want the computer to draw this part out, it gets kind of confused. It draws this, it misses everything else. This is why I'm not a big fan of this, okay? So I prefer to just go with the manual drawing. And if at any point you draw a vessel and you don't like, you click on this X here, and you click on the vessel and you erase it. Okay? So the manual drawing approach, you click on this paintbrush right here, and you kind of need a steady mouse. What you do is you kind of just go in the middle of the vessel, and you'll see it lets you freehand draw, and you go into the middle of the vessel because once you finish drawing and you release the mouse button, then, as you slide the mouse further out from the center line, you will be able to adjust the thickness, okay? And once you think that the thickness is approximately correct, you click again, and it'll keep that vessel in there. So you see, just in one shot, I've drawn this vessel as opposed to having to use that thing and draw multiple chunks. I just think it's easier, okay? So you've drawn that vessel, and basically you want to, let's say, chain that vessel. So I think this vessel goes down and then joins this segment here, okay? So basically what you have is you've drawn this, and then let's say you want to continue drawing and you want to draw this segment here. So again, same thing. You draw that to about there where the intersection is. You release the mouse button. You pull away. You think, okay, that's approximately the thickness. And don't worry too much about getting the thickness exact. Like, it's approximate. It's no big deal. It's okay. So you draw that segment. You have these two. And then you see, okay, these ones continue on. So you basically stop at the intersection, and then you draw another vessel, let's say, maybe to about here. There's an intersection here. So you stop, you release, you drag out approximately thickness. Okay, so now we have a situation where we think that we have two vessels joining together to form one. Unfortunately, there's no way for the software to make two vessels join into one. You can only join one vessel segment to another. So basically, I just choose whichever vessel I think is flowing most smoothly. And another thing that I'll mention is that this whole time, basically, while I have this screen going, I have another screen, okay, right here, that's playing the video segment in a loop over and over again. So I can see for myself which shadows are actually vessels and which are not. And I find this is a really good strategy. It was Dr. Bracco who suggested it, and I've used it for all my analyses, so I highly recommend you do the same thing. Have a separate computer with the AVI file constantly running in a loop, and basically do the analysis while watching it. I think it works very well. So basically, this is what my workstation ends up looking like. Oh, all right. You got the file looping there, and then basically the AVA file right there. And my Kleenex box is basically to prop up my camera so I can record this video for you guys. All right, so we'll just continue on here. We'll put my camera back down. All right, so just continuing on, I want to make sure that I'm not losing anything here. Reposition my camera. Okay, perfect. All right, so like I was saying, there are two segments right here that we want to join together. We cannot join a Y, two vessels into one, unfortunately, with this software. So we'll just join the one that looks like it's most likely to be flowing, or the most contiguous one. Since this one is thinner than this one, we'll just say, okay, let's just join this one with this one. To join vessels, you click on this button, the chain button. It says chain there, okay? You click on that, and then you click on the first vessel. It turns yellow, and then you click on the second vessel that you want to chain it to or connect it to. And once you click on it, boom, you'll see the little gap has disappeared. Now, don't worry too much about the fact that this vessel here connects and doesn't connect into there. It's okay. It's not the end of the world. Just leave it like that. Now, basically, once we have that chained, we can continue doing our analysis here. So let's say, this one continues on this way, and we kind of draw the center line and then approximate the thickness. And then once again, we chain this vessel. Now, once we click on here, it selects the whole thing because you chain these two vessels together, and you chain it with this one. Boom. Okay, it's done. Now, let's say you're working and you're drawing this vessel right here. Okay. And you do a nice job there. You get the thickness and everything. And then you go ahead and also draw this segment here. Okay. And then you're like, okay, I want to chain this segment with this segment here. But you accidentally click, let's say, this with, this thing. Now what you've done is you've chained this small segment with this entire thing here. If you were to choose the delete button, you would delete all the work that you've done, which is a huge pain in the butt. So instead of doing that, what I do is I use the scissors. I take the scissors and I say, okay, this is where it started chaining. I click here, it makes a little cut, and then I say, okay, this is where it chained it to improperly. Obviously, this is an improper chain, and I click about right here. So then, once I take this X, I basically click in between my two cuts, and it only gets rid of that segment, okay? So you don't lose all your work. It's just a little trick that I picked up, okay? All right, so now, once you do make a little bit of progress, you obviously want to save it because this software is not foolproof. There are times where it'll crash, and if you haven't saved it, you might have done all the analysis, you might have drawn all the vessels and everything, then it crashes and you lose everything. Don't want that to happen to you. It's happened to me, and I figured out a way to basically more or less save your work. So the way that you go about saving your work, there's no official save button, but the way that you do it is once you've drawn a certain amount, okay, you've made a little bit of progress and you're happy, you just click on this button again, use average frames again. And once you click on this, a message will come up. I'm not sure if you can read the message on this video, but it basically says analysis logbook stored to file C AVA logbook and the name of the file with the addition of the word logbook 1 to it, okay? So this message comes up and then you click the OK button and then you see you lose all your work. Don't panic, it's saved. What you do is you go over and you move your mouse to the second button where it says Review Earlier Analysis, okay? I hope you guys can see this. Review Earlier Analysis, you click on this, and then this will open up the folder that says Logbook, okay? And within your logbook, you see, this is the file that it basically warned you about. So when you double click on this, it says Averaging Frames again, it'll do its thing, and you see, boom, your work's been saved. So I would recommend doing that at regular intervals so you don't lose too much. So let's say we do some more drawing. We draw all the way here. This is a very thin one. And then we draw this one up here. Again, very thin. And then we draw some more, very thin. Okay, we've made a little bit of progress. Obviously, I haven't made that much, but you can decide how much you want to do before saving it. I want to save it again because I don't want to lose the work. Maybe these were very difficult to draw. Once again, I come over here, use average frames, click on this, and then it'll come up with that same message, but this time it'll say analysis logbook stored to file C blah, 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 logbook 2. Okay, so this is the second file. You click OK. Your work disappears, you don't panic, you go to Review Earlier Analysis here, and then you basically look for the most recent file. Now you have Logbook 1 and Logbook 2. You want to pull up the most recent one, you double click it, and it loads it, and boom, you have it with your most recent work. Okay, so I just encourage you to do that on a regular basis to prevent yourself from losing the work in case your software crashes. Now, I'm not going to draw out all the vessels. Let's say that you have basically drawn out everything. You're finished. We'll just add one more in here for the sake of it. And let's say everything has been drawn. You're happy and everything like that. What I would recommend doing to make sure that you have successfully drawn everything is to actually remove the vessel walls. So unclick this so you're no longer showing the vessel walls. And you see that now what you actually have is that you're showing just the vessel lines in the middle. And there will be different colors also. I'll just demonstrate to you. So if you have a very thick vessel here that you want to draw, as you see, as you draw out, the center line changes color from green to yellow. This is medium thickness vessels to blue. And blue are large vessels, okay? So small, medium, large, okay? Different thicknesses. Anyways, we've got that drawn in there, okay? once you think you've drawn all the vessels, you unclick the show vessel wall, so you just have the centers, and then you click the play button, okay? So this will start playing the video, and I find when you play the video, you get a better impression of if there's anything that you missed. Just looking at a static image doesn't help much. Playing the video, you can see, oh, there's a shadow that I missed here or there. So play the video, and then you stop it. Let's say you're happy with all of this. You're happy, you've gotten all the vessels, you've drawn them all in, you're satisfied. There's a center line going through every single vessel on the image. That's great. You click on Use Average Frames again. It'll say Stored Analysis Logbook Stored to Logbook 3. You click OK. That's great. So now at this point, once you've finished all of that, all the information is stored in the logbook. And the logbook is the very crucial part, okay? So basically, I'm going to do all the analysis because I'm used to it, and this just decreases inter-observer variability. So once you've drawn everything, you basically go to Main Menu, Exit, and then when you go to the shortcut to AVA 3.0, you open it up, you see in your logbook, you'll notice, okay, you have 3 logbooks. It's the most recent one that's important, okay? So what I want you to do is I want you to change the name of this logbook. At the very end, change it to Final, okay? Instead of Logbook 3, it says Final. And I want you to take this and upload it into Dropbox, okay? And once you upload it into Dropbox, I'll be able to do the analysis. Okay, so you open up Dropbox. You should have a shared microcirculation research folder. You open that up, and then you go into this folder called Data Analysis, and then you'll see another folder called Vessel Drawing Logbook. Okay, so you open this up, and there may be files in here. I've moved the ones that I've analyzed into this folder. I want you to take the one that you've changed the name to Final, and you go copy, and you paste that in there. So you do that, and it'll upload it, and that way I can have access to all the files that are basically being analyzed and that I will analyze, okay? So that's pretty much it, and continue doing that. Once you finish that, basically what I suggest is go and analyze the next vessel, and you just keep doing that for all the video segments that I've assigned to you, and hopefully we'll get through all of this. Okay, thanks very much.